Hello everyone, this is Rohan Mishra and welcome again on my lecture series on demonstrating the molecular docking techniques that I'm going to deal with in next few videos as well. So let us first revise as to what we have done in our previous lecture. So in my previous demonstration, I have kind of shown you some multiple ways by which you can uh, craft a suitable compound library for virtual screening. Okay, so let me just revise as to how and what things that we have done and how we have done those things so that we can proceed further. In this video as well, I would focus on preparing compound library as well as I would show you as to what exactly we have done in our previous video lecture. Okay, so let us start revising. Okay, so I have shown you at least 3 or 4 ways of creating those compound library. Okay, so the very first way begin with your draw software, okay, wherein you draw the structure of those flavonoid molecule, right? So this is the very structure of your flavonoid molecule. Okay, and then what you do using this draw, what you do is that you convert this two-dimensional data into smiles. Okay, and then you use these smiles, this draw, you have got 2D information in draw. Smiles are uh, representation of the same molecule in one dimension in terms of characters, and then using these smiles you can go either by two ways. You can use online softwares like we have used frog 2, and using this frog 2 we have generated you know your compound library, and this compound library is in SDF format. Okay, and you have got your 3D conformers in this case. So you can follow this path. Well, I would recommend that you follow this path when you have entirely new set of molecules that are not present in say some public databases. So okay, so like if you might have generated those compounds in your MSc project or PhD project, well, this can be one of the way you might end up with three-dimensional conformer of your multiple molecules in SDF file. Another advantage of using frog is that you can provide a number of smiles to this frog server, and what it will do is that it would kind of generate a single SDF file in which it would pack all of the compounds that you have provided. Second important advantage of using frog is that these are energy minimized. I will show you the difference when we compare it with other methods that we have used. Okay, so what are the advantage? The first advantage being you can have a single file which might contain multiple molecules in it. Second advantage is whatever 3D conformer that you generate, those are already energy minimized. Okay, now let me show you what exactly we have done. Okay, and what are the drawbacks of this? You can say you would have to manually rename the compounds. so that you can identify them when you perform virtual screening. That is, one of the downside, and these two are its upsides. Okay, well, now let me show you as to what exactly we have done in this frog. Okay, so for visualizing whatever we have done in our previous lecture or previous video, we would be using this software called as Python prescription. We would be using the same software for further molecular docking and virtual screening. And for time being, over there I will show you, or I will demonstrate you with the details of what this software is and what is where. But for time being, for visualizing our compound library that we have generated, we would be using the open babel section from this particular software. Okay, so using this open babel, what you can do is that you can load the compound library that you have generated using this button, this particular button, right? So I would go to desktop, and in this desktop we already have our docking lecture compound library, and we have this well, let us start out with this using frog. Okay, and this is the one that you have downloaded from the your frog server. This is the SDF file that we have generated. Okay, and if I click and open it, okay, now you can see that these are all energy minimized three-dimensional molecules that we have generated on this frog server. Okay, so this is 4 prime methoxyflavone. Now if you click the down arrow in your keyboard, you can browse between these molecules. This is first molecule 4 prime methoxyflavone. This is second molecule 3 hydroxy 7 methoxyflavone. Fourth molecule formon 1-, fifth molecule biochain A, then diosmine, right? hesperidine. Okay, so I would just show you as to what exactly you are looking into, and what you have generated on your frog server, or you can say from your frog server. Okay, we would be loading the same file. There are two folders and it is creating a confusion for me. Okay, and then we have to go over here using frog. Okay, browse to the folder, and I am opening the same file into this text editor. Okay, so now here I would show you what is exactly that is happening. Okay, so when I have renamed in the very first line, and I have, in my previous lecture, if you remember, I have typed or pasted the name over here, 4 prime methoxyflavone, and appropriately it has appeared over here. And I have renamed this file till molecule 7, till hesperidine. So this is your first molecule that begins with the name of your molecule, and that ends with the terminating mark for your SDF file is $4 sign. So whatever 4 prime methoxyflavone molecule that you are visualizing over here, well, it reads this much data uh, from your SDF file. Okay, so it starts out over here. Why? Because we know that the first line always indicates the name of the molecule in your SDF file, and the description of your molecule ends when you encounter this $4 sign. Okay, and then next you hit the down arrow, your molecule changes to 3 hydroxy 7 methoxyflavone, which is second one in your list, and you have also renamed this molecule over here. The name of molecule has been changed, and I said that I have done this renaming stuff till hesperidine. So now you can see over here, you can just scroll down and see where is your hesperidine. Now currently we are on this diosmine, right? Then you have got hesperidine, and then you have got hesperidine. Okay, and after that I have kind of not I have not renamed the molecule, and it is in the same format as we have downloaded it from your frog server. And by default it says that the next molecule is molecule number 8, its first isomer and its first conformer. So this is what is shown over here: molecule number 8, its first isomer and its first conformer. Now if I click over here, you can see that this is the first isomer's first conformer of this particular 8th molecule. And then you have got first isomer, and just below it you have got the conformer of its second isomer. Okay, this is first isomer, and this is its second isomer. Now you can see that there is slight difference as per the symmetry of molecule is concerned. Okay, so what we can do is that we usually need a single conformer for a single molecule, right? One conformer would be enough. So we don't want this second conformer, or if there are multiple conformers that are present in our SDF file. So that is why we delete this second conformer or third conformer if there are for a single molecule. Okay, so this is the first conformer of 8 molecule, this is the second conformer of 8 molecule. Now in case of subsequently in case of 13th molecule, as you can see over here, you have got first isomer, second isomer, third isomer and fourth isomer and its respective conformer. So we don't really want different isomer and their conformer in the compound library. It would be enough if we have a single conformer that corresponds to our molecule. So the next task would be to delete such extra conformer if they are in your compound library, and rename the molecule so that you can identify them. Well, for time being, you know that your molecule number 8, well, it might be your, well, just let me show you. Molecule number 8, first, second, third, fourth, fifth, sixth, seventh and 8th. Now you know that molecule number 8 is 2' hydroxyflavone. Okay, so you can see over here, molecule number 8, this molecule correspond to 2' hydroxyflavone. But after a month or so, you will not remember this task, and therefore it becomes necessary that whenever you open that 3D SDF file later on, you should be able to track down as to what that molecule is, and that is why we rename these molecules so that it becomes easier for you to identify as to what compound you are dealing with. Okay, so how do we rename it? It is of course very simple. Okay, you go to this SDF file, right? And what is the name of your SDF file? 8th SDF file, it is 2' hydroxyflavone. I would just go to edit, copy it. Okay, and go to that file frog.sdf, which contains all your data from frog. Okay, and I would just rename it, control V. Now this is 2' hydroxyflavone, right? We have renamed it. Okay, and we also don't want its subsequent isomers conformer to be present in our final compound library, so we would delete the subsequent molecule. Okay, so this is, you have renamed the first isomers conformer. Now you would locate the second isomer, you would select it, go on selecting till you reach that $4 signs. Okay, here we go. This is the data for your second isomers conformer, and I would simply delete it from my computer, delete using my using the delete command, or you can say delete key on my keyboard, and hence you go this way. So now you have deleted the second conformer. I have saved it, right? And now let us see by again loading in your Python prescription whether this molecule 8 has been renamed to, we'll say, what was its name again? If it has been renamed to 2 prime hydroxyflavone, right? So it is not present over here. After hesperidine you have got molecule 2, molecule 811. So after doing these changes, after hesperidine it should appear like 2 prime hydroxyflavone, and the next conformer should go away and the next molecule should be ninth molecule. Well, let us see if that thing has happened. So what you can do is that you can just right click over here, okay, and you can use this delete all so that everything goes away, right? And I will already save this SDF file. Okay, I have already saved it. Let me close it and let me try to again load the edited SDF file now. Okay, so we would go to this insert new item that will load the SDF file or whatever file format that you are using. Okay, and I will again go to the same file frog.sdf that we have just edited and click on open, right? And now you can see that after hesperidine we have over here 2 prime hydroxyflavone that we have just renamed. And now you can also see that its second conformer is also gone and we have next molecule. So in this way, all I want to show you is that whatever we have done in our previous demonstration, this is how you visualize what you have done, right? So, well, say for example, and I have already told you that one of the biggest advantage is that these molecules are, in energy minimized state. Okay, as you can see, this particular ring is, uh, not the carbons in this ring are not in sp2 hybridized state, and therefore it is not planar, right? So this is how it is, right? And over here the carbon atoms are in sp2 hybridized state, therefore it is planar, and you can see that these molecules are arranged in 3 dimension. Well, that will not be the case when we come to other method that I will discuss in a while. Just remember this, that these molecules are already in energy minimization states. Okay, already energy minimized. Okay, so in this way you would go on editing this particular SDF file that you obtain from this frog server. Okay, so you would remove the extra conformer if you have. Okay, and you would rename the compound appropriately as per your need. Okay, so this is needed to be done when you create such compound library, so that when you use the same software for docking, you would know key, okay, the results are for diosmine, the results are for hesperidine. Otherwise you would have to get satisfied on the number of compound, that this result is for compound 9, uh, compound 9 first isomer first conformer, and then every time you would have to remember, okay, compound number 9, you have to map it somewhere. So to avoid the problems that would come subsequently during analysis, it is better that you format your compound library properly in this compound library before you proceed for virtual screening or molecular docking. That would be a very good idea to do. Okay, so now let me delete all, and let me show you the final compound library that we are going to use when we perform this molecular docking, right? This is the one that we would be using. Okay, flavonoids.sdf. Okay, and you can see over here I have renamed each and every compound that we have obtained, and it do not contain duplicate entries in the sense different isomer of the same compound. Okay, we have a single conformer for the given compound. Okay, and we would be using these for subsequent molecular docking. Okay, well, now I have shown you, or I have kind of uh, guided you as to how do you visualize your compounds, whatever you have created using frog server. Okay, now let me delete it. Okay, now let us see what was the next thing that we have done. Okay, another thing that we have done is that using these smiles we have used offline software as well, and its name was OpenBabel. Okay, and using this OpenBabel we have created, three compounds in its SDF format. Okay, and these are also 3D conformers. Okay, now let me kind of show you what we have done in this case, in case of the 3D conformer that we have generated using your OpenBabel software and offline software, right? Okay, so we are going to see the thing that we have generated for these three flavonoid, right? Well, let me load these three molecules. Now we would go to this, load the file, and you would go to this OpenBabel three flavonoids and then hit open. Okay, now you can see that there is no name over here, and that is why that error message has popped up. Okay, you see, so whenever you try to load it, it would kind of show you an parsing error, because it cannot find out the names in the title, and I will show you where exactly these things goes wrong. OpenBabel 3 flavonoid, and if I open it in TextPad, as you can see there are no names over here, right? So we have used the first three compounds, right? So we would copy the name of first compound 4 prime methoxyflavone, copy it and rename it over here, right? The name of second compound was 3 hydroxy 7 methoxyflavone, right? I would paste it over here, because after dollar sign on the next line itself your compound description begins, right? And in your third compound that we have converted was formonmentine. Here we go, we have pasted formonmentine, and now I will save it. Okay, so now we have renamed the name of this compound, right? Let me close this error, right? And maybe I will right click it and delete all. I would close this error, and again let us try to load and see what happens now. We are in the same file, preparing compound library. Second method was using offline software, OpenBabel. This is the SDF file that we have generated, and just click on open. Now you can see the name of those compounds have appeared over here, and whenever you rotate it, there will not be any uh, error messages that would pop up, right? So now although you can see that there are these compounds, well, sometime it happens that these compounds are not in its energy minimized state. Okay, so it is always advised that when you use this OpenBabel for generating 3D conformers, you should always perform energy minimization. I would just show you what you can do is that you can right click on any compound. Okay, then you can use this minimize selected. Okay, and over here you can use the small molecule force field, any of the small molecule force field. Let us go on with universal force field, which is default, and select any of the optimization algorithm. You have got two energy minimization optimization algorithm over here, conjugate gradient and steepest descent. Okay, and over here you can change the setting for your minimization. We would run our minimization for 200 steps. Okay, and hit OK. Now you can see that the molecules are changing they have just slightly changed the conformation of the atoms that are present in your molecule, so that now it is in its lowest energy state. Well, it is always advised that you do such thing when you create the 3D conformer. Okay, so here we go. We have got the same well, in terms of single file and multiple molecules, we still have this advantage. Okay, single file giving multiple molecule. In case of this energy minimization, we have this it is a drawback. You have to perform energy minimization for yourself when you use OpenBabel. And still, this drawback in of manually renaming the compound also exists in OpenBabel as well. Okay, so here was the next method that we have used. Okay, right. uh, okay, now let us talk about what was the third method that we have used. Okay, the third method that we have used was, CameDraw. Instead of creating smiles, what we have done is that we have used CameDraw's 3D module. Remember? And after using this CameDraw's 3D module, we have saved the files in its single file we have done. Okay, uh, and that was also in uh, mol2 format, mol format. Sorry, we have converted the 2D molecule directly into mol format, right? And this is also 3D conformer, but in different format. In these two software, using Frog2 software and using OpenBabel, we have converted into SDF format. But using the CameDraw's 3D module that I have shown you, select the molecule and then go to edit and then use that get 3D model command. You have converted, or you have generated a three-dimensional model of that molecule, three-dimensional conformer of that molecule, and you have subsequently saved in this mol format. Well, let me show you how this thing can be visualized, right? Okay, so you have already you know uploaded the molecule. Well, for the sake of simplicity, just delete all, right? And let us load what we have done using CameDraw Ultra. Right, I think I have saved it in some different location. Teaching admin 2021, same 1 and 3, same 3, medchem talking lecture, and using CameDraw Ultra. I have kind of converted it. Let me see if I have saved it at some different location. Yes, this one was it, right? We have saved it somewhere else. We have saved it as Formon 110, right? Open it. Okay, and you can see still you have to rename it, the mol file, and that is why it is giving the same error, right? Okay, let us do the same task. Right click it and delete all, close this error message. Okay, where it is, this was the one, form110, and you can see, right click and rename it, or you can just right click and find it property. Over here it will show you the extension of this file. This is a mol file that you have generated using that CameDraw, right? And this is the SDF file. If you see the properties, this is the SDF file. Okay, so always check out in this file type if you are kind of confused what file you are dealing with, right? So it is a handy way to differentiate between the different file formats. Okay, so now we are dealing with something called as a mol file instead of SDF file. You can see over here, this is a mol file, right? And you can edit the same mol file in TextPad, give it a name, right? It was format19 and save it. Now again let us try to load it, right? We have edited this file, open it. Now see, the name has appeared, right? So in this way you can also use the you end up generating the same 3D conformer even if you use the CameDraw Ultra software, right? This is the third method that we have talked about, and this is the, you know, this is the output of such method, right? So now let us talk about its pros and cons. Let us discuss the pros and cons. Okay, so what are its pros and cons? The number of steps has been decreased. Okay, so what you have to do is that usually you end up generating smiles, and using those smiles you generate 3D conformer. But from over here, if you use the CameDraw's 3D module, you no longer need this smile step, and in a single step you would generate your molecule in 3D conformer, right? So in this case, what is its upside? Number of steps are low, or are, you can say, not low, are less when you have to generate the 3D conformer. Okay, now what, let us talk about the drawbacks. The drawback is that you might want to, of course, energy minimize it. Okay, the thing is that you have of course you have to manually rename it, as you have seen it. And the third drawback you might see is that there is no single file multiple molecules, right? No single file multiple molecules. Each and every molecule you would have to generate separately. That was not the case in case of this frog and OpenBabel, right? Every time you would have to open that CameDraw file, select that file, and then go to edit, and then convert it into mol file or get its 3D model. And it is not necessary that every time it might work the same way. Sometimes it is, it is memory intensive task, so sometimes your CameDraw might stop. That can be one of the disadvantage of using this method, right? Okay, now the fourth method that I have shown you was using, well, say for example, online resources like PubChem compound. Okay, simply go and search in PubChem compound. and you can directly get your 3D conformer. Right, and you can download it in SDF format, and using CameDraw you have got molecule in mol2 format. Okay, right, and let us see what are its ups and downs. Still you have to, yes, this is of course the number of steps are less when you use this pubchem compound. You don't have to spend a lot of time in format converting. Okay, so let us see if the molecules are energy minimized or not. Okay, let us try to see if the molecule are still there using pubchem. Okay, we have got the same form on one team, right? Let us try to upload it. This is form on one team that we are talking about. Okay, the same molecule, the second molecule, right? And yes, of course it is in energy minimized state, right? So it doesn't really matter if you if you created it using if you have created using CameDraw, whether you draw it into CameDraw, then convert them into smiles, then use this conformer generator like Frog or OpenBabel, and then convert them into 3D file and use it, or whether you use online resources and generate the 3D conformer directly, or you can use the CameDraw's 3D module, and you can have it in some different format. It won't really matter. Why? Because you can use the single OpenBabel module from your docking software to upload those molecules. Okay, that the format will not really matter, whether your molecule is in SDF format or mol2 format or mol format or even in your PDB format. It will not really matter. All you want to have is the 3D conformer of your molecule. It doesn't really matter how you generate it, and make sure that you have renamed those molecules properly, right? And if you remember, we have renamed this molecule to formon 110 in case of open this online resource like pubchem. Okay, by default the pubchem id is the name that is given to the molecules if you download them from pubchem compound. Okay, so we have already renamed it. You can check it in our previous lecture. Okay, so renaming is needed to be done for these molecules. Okay, and it doesn't really matter if you separately download all the molecules from this pubchem compound. What you can do is that subsequently you can edit this file. Okay, just if you will say, for example, if you have downloaded this uh, say some next file using this pubchem, what you can do, you can again copy that content and paste it besides this one. So you can create the bunch of you can compile the bunch of molecule one after another in a single file. That will also work if you have separately created the files in, as it might appear in case of this CameDraws, if you use this CameDraw 3D module, or if you use this pubchem compound. Okay, you would have to separately create molecules one after another, but that won't really matter, because after creating you can edit the same file by adding the information of the remaining molecules, and you can end up with a single compound library. That can also work. Okay, there would be no issue. Okay, so this is all I want to talk about. Well, I have created this visualization demonstration because I thought in our previous lecture you might get lost into the format conversion and different type of methods that we have used. Okay, so I hope in this lecture it has become quite clear as to what method we have used and what are its drawbacks and what are its plus points, right? So in our next video we would start out with molecular docking and virtual screening. Okay, so see you guys in our next video lecture.